Hello everybody, this is Miss Pi again. In this video we're going to go over the basics of exponential functions, so please find this page in your notes. It's towards the front and there's two different pages that have the exponential functions information on it. One of them has growth or increasing functions up top and the other one has decay or decreasing functions. Okay, so let's first look at our growth, and of course as I go over this, you will notice that I've blocked out some of the information on here, and the reason why is because I do not want to even talk about the natural log E yet. We'll talk about it later on next week. So I just blocked it out. You do not have to, in fact, please don't cross it out or anything. Just for right now, just ignore it, okay? So essentially, with your exponential functions, you have some number here that would be like your coefficient, and then another number that you're multiplying your a value by. So another number, and this is called your base, and then your variable is your exponent. Okay, so our variable x is as the exponent, and then if we have a exponential growth, then your b value or your base number has to be greater than 1. And that will make your y value to increase, or as x increases, your y value will also increase. So that's kind of a direct relationship. Hopefully you remember that from Thursday's lesson. Okay. One thing that you do need to notice is that with exponential functions, wherever or whatever the a value is, that is going to be your y-intercept. Okay, right here. And it doesn't matter if a is a negative number or positive number. Whatever the a value is, that's your y value that will give you your y-intercept. Okay. Next couple things you should know. Just right here, y-intercept is at 0a. And then, so the end behavior, you have a direct relationship. So as x increases, y is also going to increase. So for the exponential growth, we're going to have this little curve right here. Okay, now the exponential decay is very similar. Again, I've blocked out the extra stuff because we don't need it. This time, obviously, you're decreasing, and anytime your base number is between 0 and 1, so like a fraction or a decimal, then you're going to be having an exponential decay, or you will have a decreasing function. And this is an inverse relationship. So as x increases, your y is going to decrease. And then notice you have an asymptote at y equals 0. Okay, so we are not going to cross that line. And so hopefully you have these two pages filled out. What I want to do now, this is not in your notes. I just want to kind of go over the differences between exponential functions and power functions. You should already have most of this down in your notes. I just want to verbally and visually go over it with you real quick. So a couple things. Your power function, here's your rule. Notice where your variable is. Here your variable is your base number, and there's some value here as an exponent. With exponential functions, it's directly opposite. So your x value, or your variable, is your exponent, and you have some number for your base. Okay, and then if your base is greater than 1, then you're growing. If it's a fraction or a decimal, you're decreasing. Okay, tomorrow, or not tomorrow, yeah, let's see, Monday, when you come to class, those of you that have all your notes filled out for the 2 pages, you will have problems very similar to this to work through, and you'll be working in either pairs or groups, depending on how many of you have your notes filled out. And this is 2 different examples that you're going to get. And if you look in your notes, you have pretty wide margins on the right side of the exponential chart. So go ahead and write down some of this problem in those margins. And basically, you're going to use the formulas that we had a long time ago about exponents. Let me see if I can find them real quick. Oh, I just passed them. So you remember all these formulas, and I said make sure you memorize them. You'll need them a lot. Okay, this is also in your notes, so you can either find them in your notes or hopefully you have them all memorized. So we're going to use these values in our exponential functions as well. So these work for any type of exponents. Okay, these are just properties of exponents. And so let's go ahead and apply them to the problems that we had. Let's see, where are we at? There we are. All right, so if I had the formula with the base number 4 raised to the x minus 1 power, notice I don't have two numbers down here. I don't have an a value and a base number, okay? And then I have all this complicated stuff as exponents. Well, I want to change that so that I have the formula in this form where all I have as my exponent is my variable x. I have some a value here and then my base number here. Okay, so let's practice this real quick. Well, I know that if my exponents are subtracting right here, then I have a division. Okay, so I'm going to break up those two exponents, and I'll have 4 raised to the x power divided by 4 to the 1 power. Okay, and then I'm going to reduce or change it up just a little bit. So this base part here is just 1/4. I can simplify that to 1/4 and then times it by 4 to the x power, which is pretty easy to do. You just have 4 raised to the x power. So now my a value for this is just equals 1/4. So if I graph this on the graph, because this is a number greater than 1, I'm going to be growing like this, and my y-intercept is going to be approximately 1/4. So this point here would be at 0, and 1/4 would be the y value. Okay, notice I didn't take super long time to graph that. I just drew a basic curve with my y-intercept at 0 and 1/4. Okay, let's now look at another example. So again, we have it in this form where we have all this extra junk up here, and I have no a value over here. I just have my base number. Okay, so let's simplify this as much as we can. When we have a plus sign in your exponent, you're going to multiply those. So we'll split up these two sections. So I'm going to have 2 raised to the 3 times x power times 2 raised to the 4th power. Okay, and we'll find that this is going to eventually move up front. It'll get in front of here because I can go ahead and calculate that out, and I just have 2 times 2 times 2 times 2, which gives me 16. Okay, I can simplify this further here. Okay, this time I'm multiplying those two variables together. Well, if you look at your notes, you'll know that in order to do that, you can rewrite that as 2 raised to the 3rd power and then parentheses raised to the x power. So now I have this situation, okay, and the 2 raised to the 4th power just became 16, and the 2 raised to the 3rd power is then going to be raised to the x power. Now this can be reduced as well, so that we have 16 out front and then 8 to the x power. So where did the 8 come from? 2 times 2 times 2 is going to give me 8. Okay, so that's how I simplified that. Now I know that this is going to be my a value, and the 8 is my base, my b value. Okay. All right, so those were just 2 quick examples. Hopefully you understood that. If you didn't, go ahead and rewind the video and watch it again. You will be working with partners on several problems like this. Please, please, please practice, practice, practice. Learn how to use all those exponent properties that are in your notes. They're there for you to use. The sooner you have them memorized, the more familiar you get with them, the easier this unit will be. All right, so I hope you guys have a great weekend. I will see you on Monday.